Hi, everybody. My name is Jeff Kinsberg, and welcome to this episode of JAKTALK. I am the founder and visionary behind JAKTOOL. JAKTOOL is a precision product development and contract manufacturer focusing on medtech and technologies that support the United States Department of Defense. JAKTALK, our podcast, is where we pull back the curtain on how we take ideas to done. And our discussions cover the process, the people, from innovation to execution, and how we've provided our customers a competitive advantage over the last 30 years. I'm joined today by Kristian Mayer and Tom Blyskal. Thank you for joining me.
Thank you.
Today's topic is we're going to be focusing on the balance between part definition and modeling for design versus manufacturing. Now, I know both of you guys sit on opposite ends of the spectrum, and I'm kind of looking to get the ins and outs of how you guys straddle that divide and solve problems together. This has the potential to touch on a lot of nuances, on between the process, between the part definition, producibility, time value of money, and how the needs of stakeholders shift through the process. And that continuity from development to full rate production. The topic resonates with me on so many levels because I've sat in all these roles in a small business wearing all these hats, and thankfully as we've grown, I can remove some of these hats. But I have this deep sense of appreciation for how this balance looks and how it's given us a competitive advantage to our customers. We started out, I have an engineering degree by background, but we started out, the early jobs were contract manufacturing, and the conversations were very much a junior engineer or mid-career engineer calling me up to say, I'd like you to make this. And I'd say, I'd like to make it too, but I think you might be crazy. Can we have a discussion here to get some balance? So I've been on both sides of the fence, and that's my goal at JAKTOOL, is to create an environment where we break down those barriers, which ultimately gives us a competitive advantage to our customers. I'm still searching for the 100% solution. I feel like as a business, we're close. Hopefully this conversation will move it forward a little bit. I think all of us being engineers saying 100 is a really tough number, but maybe by the end of this, we can, shed some light for the community on how we do it and how we get there. I guess I'll start off with an example of how I came across this while I was growing JAKTOOL in the background. But for those who don't know, I worked for 5 years as a design engineer, primarily doing structural design and bearing design. And we were working on systems that were moving very large pieces of equipment. And it became apparent where I could not design things because the steel mill in the US didn't have mill capacity to make what we needed. So that's like a real easy producibility question, right? You can't design something with a slab of steel that you can't make, right? But that's a real easy topic, right? I know for a lot of us, you look in a lot of OEM catalogs and you start looking around and you can move forward with what's available. So today's topic was kind of on this short list of topics that we had envisioned for JAKTALK, and I kind of pulled it forward because of a message from the community, which I'll read. And this came over last week. So from one of our current customers, he writes in, I was talking to an engineer at our in-house machine shop, and they take our models and convert nominal dimensions that have unilateral tolerances to the middle value of the tolerance with a bilateral tolerance. This gets complicated if I use top-down design modeling. And then they're unable to make that conversion. I was curious how you guys do this, because in the past, I've only given you step files and you would not be able to make this conversion. So I guess that's kind of what's driving this conversation. But before we get there, why don't we start out with you, Tom? Can you tell us a little bit about yourself, your background, your role, and what you do here at JAKTOOL?
Sure. Tom Blyskal, a senior mechanical engineer. I've been with JAKTOOL for about 2 years now. Prior to JAKTOOL, I worked at Picatinny Arsenal as a mechanical engineer in the warheads and lethal mechanisms group.
Hi, I'm Kristian Mayer. I'm engineering supervisor of manufacturing here at JAKTOOL. Been here about 2 years. Got about 10 years experience in manufacturing various Came from an air bearing company. We delved into oil and gas, a couple different industries, superconductor, medical stuff. So a little bit of everything.
So Tom, can you give us some examples of the type of projects you work on here at JAKTOOL?
Sure. Most of the stuff I work on is on the defense side. So mixing fixtures for explosives types manufacturing to projectile forming, cold forming specifically. From, let's say, forming a projectile from a slug to a finished bullet.
Okay. And how do you work with our customers?
So we have weekly update meetings with the customer, and we go over where we currently are and cost and schedule, and where we look to be moving forward, and basically I'll keep them updated as to where we are in the process of their product. Now,
so you're working with the customer to capture requirements, nail those down, yep. And then, so I assume programmatically there's program updates, but I assume also there's additional technical discussions going on the side, real time to move the projects forward.
Sure. So if we have any questions, a lot of tech data that comes in needs revisions, right? So there's a lot of info missing on there. So we'll go back and forth with the customer and try to fill in those gaps, and so that we have a firm base as how we're going to develop this product.
Okay. How do you typically, that's usually done over email, or how do you typically share that information back and forth?
Well, I think weekly update meetings, and also if it's something quick, we'll shoot it over an email or even a phone call, try to clarify what we're trying to do at the moment.
Sure.
And it's a piecemeal. We'll work forward and keep moving forward, and one thing at a time, try to get it done.
In this day and age, the phone still works.
Yes, it does.
It's fast.
Yep.
If somebody answers, it's very quick. And Kristian, what are the types of projects that you work on?
Pretty much everything that comes in-house, manufacturing, everything from forming to a lot of enclosure stuff for electronics, some medical devices. We're holding, limbs, stuff like that for surgery support, a variety of different type of things going through the shop.
Mm-hmm. So I think it's worth noting that, I guess, the way things are situated at JAKTOOL is we do, we're vertically integrated and have that in-house manufacturing. Kristian, you support manufacturing for both of the primary industries that we focus on.
Right.
And I guess you prioritize the work that, for one reason or another, we do choose not to send out of house.
Mm-hmm.
Right. Okay. And how do you interface with the customers and work through the process?
My side's kind of a little removed, more so than design, I feel like. Really comes down to if we have a question about whether it be functionality or manufacturability of the part, we'll either reach out to design if it's, a little bit of in-house involvement, or if it's strictly a customer design, we'll reach out to them via, PM and see if we can get some feedback on that.
Cool. And I guess for both of you, how do you, Kristian, define success for your role?
I feel like that's pretty easy for me, is a conforming part. On schedule and on budget, I feel like is a pretty good metric of success for manufacturing.
Mm-hmm. That's the expectation.
Yes.
So how do you exceed that?
Try to make jewelry every time we can. It's functionality is one thing, but I always enjoy making a good aesthetically pleasing part too.
Sure.
So.
It's tough to convey to somebody who has that passion for manufacturing to, we don't need
dial it back.
We don't need a 63 surface finish and everything.
Right.
We can, sometimes 250 is acceptable.
Yeah.
Right.
Let me hit that with some sandpaper. I'll get right back to
you. and Tom, how do you define success with the projects and your customers?
Meeting all the requirements and then exceeding them as well. Say if the customer wants a part or assembly or a project to weigh, say, 100 pounds, we come in at 80 pounds. Well, I would think it's a bonus for them.
Mm-hmm.
They're looking for efficiency in there.
Yeah, absolutely. Awesome. Well, let's dig in. So this kind of get kicked off of this person writing in and finding the balance between design versus manufacturing. What I want to spur is who's right. Right.
I am.
I maybe. So I think what's interesting here is we span this a very broad development process, right? So you have some product development firms that are primarily focused on the front end design and some light prototyping or some rapid prototyping. I've always argued that, what is light prototyping or what is rapid prototyping? Most people want the real functional thing as soon as possible, right? With, and then all of a sudden, a light switch flips and it's, I got my thing, I want to put it in space or I want to use it in the OR, and you've got all the, the QAPs and the pedigree and the certifications, and you go, what? That wasn't a requirement. Where did it say that? So because we span so much of the process, the idea is, how do we know, when this is a more design focused activity, and Kristian, for lack of a better, way of putting this, you're just going to make it and smile, right? Have your team make it and smile. And then how do we know where we get to the point in the process where, all the options have been exhausted, both internally and externally. And the feedback from the PM is that this item on the BOM is driving too much of the cost of this product. And then we look back at Tom and say, what did you design us? This is very expensive. Right. So I think there's this balance in the project flow of design taking more of the initiative early on. And then once you get past certain gates, it becomes a cost, it becomes an activity in managing cost. Right. So I guess starting out, Tom, how do you tell somebody to design something using an end mill and not having a 20-to-1 length to cutter diameter? Make it easy.
I guess you have to first start off with the requirements, I believe, right? So have a clear and concise requirements doc, and then from there, design for manufacturability, I believe, right? So, you have to look at your design and make sure there's no holes or something that are like you said, 20-to-1 ratio in depth. Just take that into consideration while making your designs. Make sure things can actually be made. Sometimes you have to break the part down into two pieces versus one because it's just impossible to manufacture at the cost that you're willing to pay for it.
I have this discussion with my peers that I went to school with, who I think are pretty talented engineers. I was fortunate to go to school with a bunch of fellas that you probably know some of them, Tom, from Rutgers, and I felt privileged because there's engineers that get very passionate about the topic, and it's really a diverse field, but we were all mechanical and we would obsess about structural design and flow and does it look right. So there's a point where when you're looking at something, whether it looks good or not, and you have that gut feel, right? And then that gut feel kind of starts to drive design decisions of, I think that we're going to have a problem sourcing this or have a problem making this. And you have those early on instinctual cues, right? Which we're ahead of the whole tolerance discussion yet of how you design something, but you'll have those instinctual cues and you'll talk to your team and say, I don't know, I think I strongly suggest that you break this apart here.
Sure. There have been instances when I've worked with early on in green engineers, if you want to call them that, and they're designing square holes for no good reason. It's
right.
like, well, they would try to be creative. I'm like, that's a bad avenue to go down. Just keep it simple.
Too creative.
It's for the carriage bolt.
Yeah, exactly. Right. But no, they need to take a look at their design intent and kind of, making it look pretty is one thing, but making it function is probably above and beyond where it should be.
I feel like computers have a little bit to do with this too, because you always get the, real life to computer screen disassociation, where it's like, oh, it's not that bad. Look, I'm zoomed all the way in on this part. How come you can't make it? It's right there. And then you're like, actual size is 20 thousandths radius, and you're like,
very deceiving.
What's going on here? Like, it's. I feel like maybe 3D printing might help out a little bit with that. Of rapid prototype something, even if it's just quick, and you actually get a real world result out of it. It might, kind of steer some greener engineers to, hey, this isn't really attainable. Let's rethink it.
Yeah, it makes me think. So it makes me think about, you're talking about zooming in and putting fillets or chamfers or radii and things. And I remember as a young design engineer, you click the button in CAD because it's fun, right? And then it looks beautiful. And then you like go over to the milling machine or the lathe and go to make it. And I'd go, yeah, I don't need that. Nobody's got time for that tool change. File's good enough, or I chipped the corner off my end mill. That whatever that fillet is what it is
perfect.
Now.
Yep.
Right? So how do you in the design process, how do you work with Kristian releasing drawings? I know we do. It's interesting. We've kind of grown into this space where people in the industry kind of refer to things as like tool and die type work, and I don't know what that means anymore. I kind of say, you mean you want very precise things made to print? Like, does it need to be a tool or a die? I think there's an order of magnitude of tolerance associated with that, but we've gone down that path of making a lot of precision tool and die work, like you said, for forming of products, and it's very precise, and we're laborious. We beat it to death. But how do you work with Kristian on those types of projects to get that feedback so when prints go to the floor, the team can make them?
So I guess depending upon the complexity, and a lot of time, I think right now we're pushing our drawings through manufacturing for prior to release. This way we can get concurrence from manufacturing that, yes, this part's, able to be made with the tooling and the equipment that we have here in-house or really anywhere, especially since we're, at the cutting edge of some of these tool and die, dimensioning that we're dealing with. Yeah, the whole design for manufacturing and including manufacturing in that before that release process is, I think, is key to guaranteeing that we try to stay at, Rev Dash versus going through Rev C, and making parts that don't conform or are impossible to make, and having to reiterate that process of redesigning a part because it's not capable of being made.
Sure.
With the way the drawing is at the moment.
Sure. Now, I guess before I've overheard some of these discussions, and I guess I was listening to you guys talk about a 45-minute discussion of a circular loop of how some GD&T and a feature control frame kind of references itself. So can you explain a little bit more about that, what that was? Because I thought that was interesting.
Yeah. When you have, I'm trying to think of like a good example of it. I guess if you have say like a cylinder and you have a hole in the end of the cylinder and you're going down the axis of that cylinder and you want to control basically how straight that hole goes down that cylinder, your first datum is going to be the end of the cylinder because that constricts you in 2 degrees of freedom. So that's going to lock you down basically the 2 axes of the cylinder, and then all you're left with is the axial depth. And, that's up to you if you want to control that or not. Some of our forming dies have geometry that almost, it's the nose of a bullet. So it's going to have some change in diameter along the length of it. And that will, unless you're mating it with another part, it doesn't really matter where that lies along the actual part itself because we can control that displacement later on in the process. So it's not really there's a discussion of, do we need another datum to lock this down along the axis? And it's like, no, you have a profile tolerance there that's already going to control it. You have some radial tolerance that's going to translate to an axial tolerance within that same window. And you don't really need to lock it down. You're just going to overconstrain it. You're just going to make it a little bit harder for people to understand what's going on. And it's not necessary. So it's, certain situations dictate certain requirements for GD&T. And sometimes, I'm guilty of it too, of overthinking it and thinking it needs to be completely locked down. And it's like, it kind of already is. You really don't need it because it's, the way I like to look at it is an internal versus an external system of a control system. It's all these inputs are internal to the part. Like nothing you change in this part is going to make it any different looking from the outside. It's just the later steps that we're going to need to tune in are going to be, a couple thousandths off because it's sitting lower in the die. Yeah.
So I think, that's beyond my GD&T knowledge. I don't wear that hat. I don't think I ever wore that hat really well. So, but that discussion right there is something that could be very laborious in some organizations, regardless of scale, right? But we need to have that discussion, right? We need alignment from manufacturing to design and vice versa. That, Tom, you feel comfortable releasing drawings that are going to keep the program at low risk and hit the design intent. How do you? So, any suggestions for the audience of how we achieve this? Is there magic or beer?
Communication, really.
I was going to say communication.
As you're designing, just make sure that you're on track with the capabilities of the shop itself. Don't over design. keep it as simple as possible while still being able to achieve its form, function, and fit.
Mm-hmm. So what you said, so Tom, I know that I know life is busy and you probably don't get to do it as much as you want, but I know that you're very hands-on outside of work.
Sure.
Right. We've talked about tractors and home projects and stuff. So I think you have a natural eye for manufacturing, right? So, you might not know the 100% path, but you've got a really strong, gut feel of you're going to ask somebody to do something that's plausible or not. Do you have any suggestions for, students or people fresh out of school that haven't done anything? How do you design something, that needs to be, whatever manufacturing, how do you design something for a manufacturing process that you've never had hands-on experience with? Any suggestions?
As a kid, I was taking a lot of things apart, and even if they were working, if they weren't broken, and just to see how it functions inside. So I think it's just exposure, really, to all different aspects of mechanical movements and design. And you just got to get out there and either
ask questions. That's my answer.
Ask questions, sure. Absolutely.
Figure out the 5 whys of why. Well, it controls it because of this. Well, why? And then,
sure,
you get to the end result, and hopefully that's enough whys, but maybe not.
And hope that your parents are kind to you. That hey Tom, how come I can't find my chainsaw? Well, I put the motor on a scooter. I hope you didn't need it.
Yeah.
Right. So
that and tools laying outside all over the place.
And okay, so it sounds like the way that this kind of gets solved quickly is just through communicating, or maybe even overly communicating. It's difficult to put, we talk about processes here, and I can't believe for a small business how many processes we have. I'm proud of that. I'm also really happy that I didn't have to come up with those processes. That's not my strength. But you can put all the process in place, but if you don't have certain fundamental, values, like we talked about communication, which is one of our core values, it doesn't matter if, the process can say, go talk to somebody, but the conversation needs to be purpose and has purpose and meaning. Without that, you're just checking the box and you're not really solving the problem. Right. So that's important. And it's tough, like for people to know how much to communicate or how little to communicate, right? Your team could be going to Kristian's team and 20 times a day. And then it's, I'm trying to work out here. Can you let me focus? Right. So I know one of the things that's come up is I know there's an infinite number of situations of good design versus bad design, like we talked about length of diameter, or I can't cover it. There's too many things. But one of the things that's come up is this idea of top-down manufacturing, or modeling for design intent, right? Where if you're gonna design you design a hole, you put it at one end of the tolerance range, you put the pin, you put the other end of the tolerance range, but the fellow making the hole or the pin lives in a bilateral world, and they're going to change the CAD, and that those are really easy examples, right? Like we talked about servicing and stuff. So what happens in the process to take the CAD data and then program off of it and get parts that make Tom happy?
That goes back to the communication part of it, is really when you communicate a GD&T, specified on the part, you're really demonstrating the intent of the part through that, how it's going to work. And, I feel like maybe sometimes the lines get blurry if you do, going back to the green engineer thing, if they're just throwing block title tolerance at it, or just, hey, I really don't care about this, I'm just going to throw this, 10,000 profile tolerance on a part that has 50 thousandths of clearance on it. It's like, what's the intent there?
I haven't seen it, but I feel like there could be like the wall of thou shalt not do in design, right? Don't do this whole list of things. What are common things that you frequently see that you need to re-enlighten the team on to do or not to do?
I'm not going to throw our team under the bus here because I really don't see it that much. But corner radii and edge breaks are pretty much the biggest thing.
Inside corner.
Yeah. So, if you have like a, I don't know, 50 thousandths radius and it's down 2 inches into a part, that's asking a lot for, standard, I would say standard machine tools, lathes, mills, stuff like that. Certainly more attainable if you do EDM stuff, but it's still probably a little bit cumbersome because you have to find a way to verify that that's straight and qualify it 2 inches down. The mating geometry might be wide open and there's no really reason to have that there. I would say that internal radii are pretty much the bane of manufacturing existence for that type of deal.
You said qualify and validate, and I'll add verify.
Right.
That's another podcast. That's
nice.
That's a whole nother topic. So we're just going to assume everything you make is
it's good. It's jewelry.
It's in process, inspected, it's perfect, and
Yep.
it goes out the door. All right. So the is there anything yet that you've thought about or you're working on, with the rest of the department at large of ways to, I know we have an engineering handbook, a design guide of how to do things. Does that touch on any of this or not to that level of specificity?
I think we could definitely work on it. I think what I've seen a lot recently is basically screw thread design.
Mm-hmm.
I think we need to standardize that and basically a quick lookup. I think that would be much better because I feel like sometimes the younger engineers are using screws that are way over the top in terms of strength and pull-out force that's required for their design. I think I think the design guide, we could definitely put something like that in there for screws.
Yeah. It's that's not something you learn in school. Ideal, but ideal isn't always
Reality.
Reality. So I guess we were talking earlier at our weekly update meeting about an NC on which came about because we accepted a contract manufacturing job. So we accepted a contract manufacturing job where there was a thread call out of plus or minus 5 thousandths tapped hole, right? Which is using the UOS block, unless otherwise specified block on a drawing, and it's quick and easy to do. And the engineer says, I don't want to think about it. Just it's going to be good. But what does that do to us, right? It turns into the cost of poor quality and discussions and NCs. So that's something we always have the opportunity to catch earlier on in the process. But it's, how do you, I guess it just goes back to how do you know when you're making a prototype and it's, close is close enough versus you're making, hardware that's production representative that will be released for market research or field testing. And, it needs to be perfect. So I know internally we have our different quality levels and procedures and we flag the jobs a certain way. But it still doesn't solve the problem of how we communicate outside with our customers, right? Because we've got this very, we're getting better at it over the years. Sometimes it feels cumbersome, right? Where we ask the customer, what do you need? And they're like, I need my part. Okay. Well, do you want the part validated? No, I just need a thing to get through a quick demo. Okay. Well, so we start asking the questions on the business development side of what does success look like for you, right? Which is an internal conversation that essentially you'd be having with Tom, right? Tom being your customer, what does success look like for you? But it turns into this whole vocabulary of the why, right? Of what's driving this. And, you might have a drawing, the part might match the drawing. It still might not meet the why, right? You can deliver and say, I did it, but you knew that the person, maybe you scratched your head when you saw a call out on the drawing and it said to do something. And you're like, I don't know if I feel so good about doing this, but I will, because that's what I was told to do. Right. So it's like finding that balance of meeting the design, the print, this is like the legalities of scope and scope change, but also, being true to the customer and saying, I'm not going to do this without asking a question to somebody, because I think we're about to go down a murky path, right? So that conversation's happening internally between you guys, right?
Absolutely.
Yeah.
I mean, I think it's kind of crazy to have a thread called out to a depth of plus or minus 5,000. I think it's probably something that definitely was overlooked. And I think, I think that's something that, when we go through, design for manufacturability, I think that's stuff that we would definitely catch in here for sure.
Mm-hmm. So, but going back to having, CAD with top-down design modeling and CAD for manufacturing, how do we solve those problems? What do you do, Kristian?
I think the voice of the customer has a very large input there. It goes back to intent, right? It's an understanding. It's not that we're just going to say, okay, we're going to make these parts to this print, and if it's wrong on the print, oh well. Like, we're going to try to give the customer what they want, because we can understand and put that time into developing a process for them to get the part that they want, not necessarily what they think they want. If that makes sense. They might have some idea in mind where they're going to, present us with this drawing, and we're going to say, hey, why don't we do this instead? Because, I guess that's part of the DFM loop of it's easier, but if it's easier this way and it's going to, save you more in the future and make it easier for us to boot, and it's kind of a no-brainer of, hey, let's do it this way. So I feel like having that disconnection from engineering to the shop is a large hindrance, and we don't have that here, whereas it exists other places.
Mm-hmm. Yeah. That goes back to what I was saying about trying to build a business with as few barriers as possible to move quickly.
Right.
So just because this always piques me, is you talked about a loop, and I know engineers like to go in loops, myself included, and make things 100%, and it just, you go into a time vacuum and you come out, and then how do you know when you've been in the loop too long?
Look at your schedule.
I don't think I know when I've been in the loop too long.
You look at the schedule when the customer or the program manager or somebody representing a voice of customer says, let's go.
Yeah. There's some self-awareness there that needs to happen too, of, I always like getting jewelry out, like I said, so I'm going to spend the extra 5 or 10 minutes if I can, but hopefully that 5 or 10 minutes doesn't evolve into 50 or an hour's worth of time, chasing your tail at that point. So I rely on PM to tell me when I should stop.
So you've got so operations has their head down, and the program manager has their head up, saying, let's go.
Yeah. Yep.
It's interesting and that's a really tough balance. I know I've worked with people very close to me who actually this is my father-in-law in particular, lifelong machinist, tool and die maker. He retired from JAKTOOL as our quality manager a few years back, and he would say to me, he's making the perfect program. Whether before he was in the quality role, it was the perfect program for machining, or when he was in quality, I made the perfect program for the CMM. And I'm going, are there shades of perfect? And he'd say, well, it's perfect. Look at the code. I'm like, nobody's making code longhand anymore. It's just brute force code. And then I'd say, well, how long did this take you? And he'd say, it didn't impact the job because I just worked through the night. And he derived a lot of satisfaction from this, right? Like, and so does his daughter, who's my wife. But there's a theme there. But we don't all have nights to just keep going. And like, I guess, like you said, between you two guys looking at design intent and balancing it out with what the program manager says in terms of like owning the delivery to, that master schedule to the customer, you go as far as you can till, the risk is low and you run out of time and you move forward. Yeah. Mm-hmm. What are some examples of projects where you've worked on where you guys have been at odds? And don't say there's no odds.
We always get along. Oh,
yeah. Oh, wait.
We can't say that? No, I mean, I feel like that one discussion we had about
The datums.
the datums
Yeah.
was, I'll admit, it was an eye opener for me. Tom was right. One of the very few times. No, it was good though, because it was, I thought I understood it the way that it worked, and turns out I wasn't. What I was saying was correct, but I just didn't believe what I was saying, and I had mixed it up a little bit. And then, through that whatever discussion we had, it was like, man, the idea was there, just the execution wasn't right, and we all, agreed upon it. And I learned something that day, and
Again,
I guess we were at odds, and now we're not.
No.
So does that count?
Sure. I mean, it's communication and willing to listen to others, and you just got to keep your mind. You can't put blinders on, because that's going to send you down a bad path.
Right.
Got to keep your eyes open for new ideas all the time.
Yeah. I've been told that the most important part of communicating and being a good communicator is listening.
Mm-hmm.
That's hard.
It's shocking, because it's like not at all communication. That's all about talking, isn't it? Not about listening.
Yep. What are some I guess, just kind of as we wrap this up, what are some recent without getting into the specifics, any highlights or accomplishments, things that have kind of been fanning your flames lately that you'd like to share with the audience, relative to design, wins with customers, customer feedback, or manufacturing? Anything stand out? I know you've done some pretty cool test mounts lately, Kristian.
Test mounts
was more for ballistic testing. I know that was more customer driven design, but that was a recent project we just completed.
Yeah, no, that was what several 6 or so mounts that we built. Mm-hmm. Ground up. Probably got tech data from customer, and built it all through to the end. Had some trials that we needed to work through, and problems that we need to solve. But that's what we do, and it ended up being very successful. Customer was real happy, and it worked well.
Yeah, I know that project. I know that the test engineers took it out to a test range and put them through their paces, so that the customer had validated hardware, which was good.
Yeah.
I think one of the things was a first for me. I think also a first for JAKTOOL was actually developing a bullet progression, and then actually getting a jacket formed in-house on equipment that was actually developed by JAKTOOL as well. So I think that was a very exciting and interesting and very nerve-wracking project.
I don't know if it wasn't nerve-wracking, would we do it? If somebody else would do it. If it was easy, everybody could do it. Right. Yeah. Well, I just want to say thank you guys, Kristian and Tom, for joining today for this episode. I really appreciate your time and your thoughts, and I appreciate our audience. Thank you for listening in, and please follow us on social, and check us out on the web. And if there's anything we can do to advance your programs from idea to done, please reach out. Thank you.